Hey guys, welcome back to another video, and today we're going to look into Python generators and some of the important concepts and some of the interview questions as well. Some things that I've seen throughout when I was learning generators and some of the quirks and just important things to know in general. So first of all, let's go ahead and demonstrate why this is important. So just have a simple function here and a train CSV file, and as you can see it's 7 gigabytes. So if you were to do it normally and you want to read some lines and the point is you just want to read the first 10 lines. So if I went in and just read all the lines, as you can see, let me just open up my task manager here. As you can see, the RAM is just creeping up. So now currently it's at 2 gigabytes and it's just taking a very long time here. So it's still running, it's still running, it's still running. And eventually the RAM will just creep up all the way up to 7 gigs, and this is not what we want if you just want 10 lines here. Okay, so it's gonna wait a while and see if it managed to read. But as you can see, it took very long time and took a lot of memory. So a better way to do this, just a quick demonstration, we'll go through how generators work later on. So let's call this generator, and instead of that, we will do this in a lazy manner. So instead of actually reading all the lines, we will basically just read the lines as we need it, so in the form of a streaming manner here. So let's comment that out. Let's call this read file gen. Let's notice how much faster this takes. You can see it was instant. So what exactly is going on? First, the intuition is simple. So the first one, we are reading all of the lines here very slow, and in fact it takes a lot of memory. And for this, we are reading lines as we need. So imagine streaming data as we need. So this is a much more lazy manner of reading data, and it's a much more efficient way. Later we'll see how much memory it's going to save. Okay, so let's look into how generators actually work. So let's start with some simple generators. So let's get generator function here. So just imagine generators giving you data as you need it. So the first keyword that we should learn is yield. Okay, so when we yield, this value is then given to the caller. So let's try U1, let's try U2 here. Okay, and to create the generator, it's very simple. Just create a variable here, and then just call the function. So when I print the type here, you should see that it creates a class generator here. Sorry if it's a bit small. Yeah, so it just creates a generator here. And one thing to take note is that this generator has not evaluated any value yet. Alright, so let's check the size of it. Keep this value, this 176 bytes here. So let's say I added more yields here. Okay, we will imagine that there's more values being yielded. So should the size change? Well, not so much. It still remains 176. So it's basically lazily evaluated here. So let's just go back to the same two yields here. Let's just comment all that out. And let's see how to actually get the values. Okay, so the next keyword to learn is next. So simply just call next on your generator here. And this will evaluate the first value, which gets 1 here. And then call it again, and then you should get 2. So this will evaluate to 1 and 2 here. Okay, so now I'm probably asking what happens when you call next again and there's no more values here. So this is where generators again become useful, because it handles your stop iteration. Literally the exception that's thrown is called stop iteration. So let's demonstrate that. You get thrown an exception, and it's called a stop iteration here. So to fully exhaust a generator, you will basically call next on it multiple times until you get this stop iteration here. And that's how the whole basic generator works here. Okay, so let's compare it with let's say we have a return function here, so the one that we are more familiar with. So let's say this one returns a result of just 1 to 10 0. Okay, so if I call this, we'll expect this to be, oops, my bad, let's get rid of that, 1 2 3 4 5 6 7 8 9 10. Okay, so let's just create this dynamically. Let's again get size of results, and let's get another result which is bigger of 10,000. So this is eagerly evaluated. So once we call this will actually go ahead and actually get all the values from 1 to n. So go ahead and get the result of that. And notice the byte size is actually way more different here. So 184 bytes versus 800,000 bytes for this value. So of course we're actually evaluating about 100,000 integers here. So we expect that each integer is about 8 bytes, and there we go. The size is much bigger. So how do we do this with a generator? So let's try this. Okay, so if you want to evaluate all values from 1 to n, but you want to give it in a streaming manner, so as the user calls it, we'll give it to them. Just simply yield I instead. So let's say we'll call, let's create a generator first. Let's just call next on this. I'll show you what's an easier way to do this, with how for loops work later on. It's not good. So we get 1 2 3 4 5 6 7 8 9. Yeah, so in this case we'll basically call next about 9 times here, and just get the next values of 1 2 3 4 5 6 7 8 9. And this doesn't matter if it's 100,000, right? It's still as fast. And let me just demonstrate that with 2 generators here. And let's just call it a very big value here. And let's go ahead and print the size of F and F2 here. Notice the size is exactly the same. So that's the key important part to understand, is that we lazily evaluate for generators. We basically yield as we need. So we call next. Okay, so the one thing to appreciate is that generators do not store everything in memory as compared to, let's say, using like a basic return function where we have to evaluate everything, put in an array, and which can actually get much bigger in size. Okay, so let's go back to this and demonstrate for loops with generators. And I think this is the key important thing to take note of. So let's say we have a for loop here. Oh, sorry, let's say we have a generator here. Okay, we simply just loops from 1 to n. Now, we can actually just use a for loop to iterate through this. So let's demonstrate that. So F. So we don't actually have to keep calling next on this, and you notice that it just calls 1 2 3 4 5 6 7 8 9. If I call 100, no, it just goes out and be 100. So what goes on here? It's important to take note of. A for loop first calls iterate on subject here. So in this case it's f. So it first calls iter f, and for generators basically returns itself. Okay, so it calls iter f and then f just returns itself. Then afterwards, it will call next on F as many times as possible until it throws stop iteration. And if you recall, stop iteration is thrown by a generator once it runs out of values here. Okay, so the for loop captures this. So that's one quick way of actually using for loops to actually iterate through our generator. Okay. Okay, so the next thing to take note of is exhaustion. Okay. For exhaustion, let's go back to our example here. Let's say I complete this loop here. So here's 1, 2, 3, 4. But what if I go on and call for I and F and then just continue print? Notice there's nothing being printed here. Okay. The reason being is that generators are exhaustive. So once we complete the iteration through this, there won't be anything to iterate through afterwards. Okay. It doesn't simply just reset when I call for I and F again. This F has been fully exhausted, and there's no way to get back to it unless you call, unless you create a new generator here. And that way we can actually create 1, 2, 3, 4, 1, 2, 3, 4 again. So another thing to take note is that generators are well exhaustive here. Okay, so one more quirk to learn is that it's just list comprehensions and generator comprehension. So let's say we have a normal list comprehension here of a very big number, and then you simply, for generators, it's just going to use brackets instead. So again, to demonstrate the importance of generators, let's look at the size difference between these two. Notice the first one is much bigger than the second one because this is eagerly evaluated. So we can actually go ahead and access list -1. Whereas for generator, this is lazy, has not been evaluated yet. So to get the last value, you have to basically next all the way until the end here. But this is much more efficient on memory. As you need the values, then you will get the values. And that's the important part of this. Okay, so that's the basics for generators. And let's look into more interesting questions. So let's look into reading files and trying to yield values here. So going back to the first demonstration, where the part where we almost exploded our memory by reading the entire CSV, let's look at how we can actually do it efficiently by using generators. So let's go back and recap. So let's get read file and we have a file path here. So let's just open the file here, and you want to read here. Now, instead of actually going and read files and read all the lines here, we don't want to exhaust our memory, but we want to actually get the lines as we need it here. So simply for line in F, just yield the line. Okay. So as the generator keeps on going next, we get a line from the file as we need it. Okay, so let's create the file, the generator here. Then let's just read the first 10 lines here. And to do that, you just simply call next. We call it next 10 times instead of it. So as you can see, we get this file here, this file here, or this file, this line, we get about 10 lines here. Basically, this is just some machine learning data. Alright. Okay, let's look into other types of questions that might be asked. Let's get Fibonacci, how to implement a basic generator, Fibonacci with generator. Infinite Fibonacci generator essentially. So let's say we have this Fibonacci function here. Remember, Fibonacci is just adding the two previous numbers here. So a equals 0 and b equals 2. Now since it's infinite, we don't really want to end it, but we just keep yielding the values as we next and so on. So ua, and then just replace it with the new values here. Check this, just create a generator functions here, and let's look at the first 10 terms. Very good. 0, 1, 1, 2, 3, 5, 8, 21, 34. And again, to drive the point, doesn't matter if it's an infinite generator or not, the size will always be fixed here. So it's going to be 200 bytes regardless if it's infinite or not, because the values has not been evaluated until we call next f here. Okay, let's try to look at more interesting questions. Let's get a simple moving let's get like a moving average window type of question there. Okay, so let's try a different new interview question. So this is just a simple moving average type of question. So as the values come in, we just calculate the moving average and calculate it in windows. So first window is 1, 2, 3, which has a moving average of 2 because total here will be 6. Then it'll be 2, 3, 4. So here the total will be 9. Then 3, 4, 5 will be 12. 4, 5, 6 will be 15, and the moving average will be 2, 3, 4, 5 accordingly. Okay, so to create this, first we need to take in our values here, and then we also have a window size. And I'll be doing this with DQ here, or deck, how you guys pronounce it. So create our DQ here, and as the values come in, I just need a variable that tracks the total here. So total plus IQ, then values here. So this is just how we do like a sliding window type of algorithm here. So how you do it is really up to you, but it's just the way I do. So if it's now bigger than the window size here, then we just simply pop from the left side here. Then if it's our window size, this is where we just yield our moving average here. So to demonstrate this, just and then just iterate through. Just go through all the yield values here. So you can see it'll be 2, 3, 4, 5, 6, 7. Yeah, so it's just different windows here. Just to show you what the windows are. You can see maybe 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, and the corresponding moving average for that. So that's how you do like a moving average type of system using yield here. Just almost same logic as how you do it in an eagerly manner. Just replace it with the yield. That's all. Okay, and one more concept I think is also quite important is send. Okay, so for send, let's demonstrate it with this. The thing about generators, it's not a one-way thing that people would misconcept for. Like if you use me, then I just take it. You can actually send values back to the generator here. So let's say I have this send here, and I create next as here. So if we print here, we get 1 here. Okay, and let's say we print this again, we get a none here. So this none is basically this new value, right? But you can actually send a value here. So let me demonstrate this. So print next as will now yield 1. Now one thing to take note of this is just to remember this point. Once we hit next here and we yield the value here, the generator is now paused here. Alright, so if I create, so let's replace this. If I now call s send 10, this 10 goes into new value here. Okay, so we just to answer again, next s yields 1, yes, pauses the execution here. So now send will now put 10 into the new value here, and then it goes on to yield the next value. So it's 1 and 10 here. Okay, so let's say I get 30 here. Again, go line by line. We create the generator here. Now, next as yields 1, pauses at line 2. Okay, pauses at line 2. Send now puts 30 into new value and calls next, yielding new value here. So now we get 1 and 30. Okay, so let's try this again with another value and yield another 1. Okay, so now you yield value, now you pause at line 4. So let's call it s.send 50. Now I get 1, 30 and 50. So just one more recap. Next s yields 1, pauses at line 2, send 30, 30 gets put into new value, and calls next, so you will now yield new value, so it pauses at line 4. Now you send 50, so now 50 gets put and now you yield another one. So send basically yields the value, puts the value into the current line and then calls next, so yield the new value. So let's look at a more complex example here. So let's look at so this function will take in a bunch of values as the user sends it and calculates the running average of it. So we don't expect to have any sort of iterable that we pass in, because there is no values in the start, so we're going to accept values as well. Okay, so we have total, which starts at 0, and the length, which is 0 as well. So the average that for now will be 0. Okay, so as we get in values, we calculate the total and calculate the length. So we put it in a while loop, so we can just keep getting values from the user. So first thing we want to do is yield the value of average first. We want to have a starting point for the new value. Okay. So the frame of thinking is this. I don't have any values first, so I'll yield a default value so that I can actually take in a new value from the user. Then total will be added, and length will be added. Now average will be total divided by length. Okay, so let's try to see what's going on here. Okay, one thing to take note is that you should not send any values right away without calling a next on it first. Reason being, we want to prime the generator first. So if you do this, you actually get an error. You cannot just send a value to a just started generator. So we just call next s first. Reason being, as we went to the demonstration earlier, we want the generator to pause at line 6. As a matter of fact, we can print this out and actually get 0. Or I can actually demonstrate it better. So now we have average, and if I print this, you actually get just started, so nothing here. What am I saying? Nothing here. Yeah. So now we can actually go ahead and send the values into this. So let's go ahead and send 10. So what this does is that 10 gets put into new value and then calculate the new running average. So So now you get 10.0. Okay, so let's look into this again. We call next as, we pause at line 6. Now when we call send puts the value 10 into new value. Total adds in length, that will increment by 1. Calculate the new average, and then since we're calling next again, this next will then be yielding this new average. So that's why I get 10.0. So now we again pause at line 6. So let's go ahead and send another value. So now we should expect to be 15, because now there's two values here, and the total is now 30. And if we go on, now it's going to be 20, because now the total is 60. So that's how you can basically do like a streaming type of average system. So that's all basically is for generators and some of the common questions that kind of saw during my study, studying for interviews and so on. If any questions, do let me know in the comments and I will try my best to help you. So thanks for watching.